All right, so we've covered dosage calculations in our first module. Now we're going to move on to flow rate. And these are going to come in two different forms. Obviously, the basic one that we're very used to, milliliters an hour. We're solving that, we're just putting milliliters over hours. Another one would be that old school method of how we would determine the patient's flow rate just based off the drops dropping through that chamber. And to do that, it's going to be a real simple equation. When you see an IV, they've got that drip chamber and those drops. We can actually use the speed of those drops to calculate how fast that patient is infusing. And to do that, we're going to use milliliters times GTTS, that is that drops per milliliter. It's going to be right there on the outside of the package, and you'll see what I'm talking about if you look at our practice worksheet loaded on the LMS as well. And the thing that always trips people up is it always has to be divided by minutes, because what that is telling you with a drop factor of 10 drops is going to equal 1 milliliter. And what we're doing is figuring out how many drops in 1 minute, what does that equate to for that patient? So let's look at our first problem on our practice sheet. We're infusing 1,500 milliliters of lactated ringers over 12 hours with a drip factor of 15 drops per milliliter. So 1,500 milliliters times a drip factor of 15. And then we're going to divide that by not 12 hours. That's going to be 12 hours times 60 to give us 720 minutes. And this will equal 31 drops per minute. Another key thing to remember is that we can never give a part of a drop. So again, we're just using basic rounding rules. If it came to 31.5, the answer would have been 32 drops. In this case, our answer came to 31.25. So we're just going to round that to 31 drops a minute. Let's do another one. For our next one, we're giving 300 milliliters of ampicillin to infuse over 40 minutes with a drop factor of 20. Again, milliliters, 300 times a drop factor of 20 divided by 40 minutes. And that's going to equal 150 drops a minute. Milliliters times the drip factor divided by minutes, and that's all there is to it. Anyway, we'll do some more practice problems when I see you on Wednesday. And again, if you have any trouble with these, I'm always happy to jump on, and we'll run as many problems as we need. Otherwise, have a nice evening.